So let's build on this a little bit and look at our space program. So how do we take this idea of input in terms of mouse and keyboard events and get them to do what we want? We're going to start off with just the keyboard, and then we will apply this to the mouse. What I've created is just a really basic version of my space program. The way that it works is that I have the X and Y position of where the spaceship's going to be. I have its speed. I'm going to set it up as being sort of a quarter of a pixel, and then the angle is going to be at 0, so that means it's going to be going in this direction. So if I run this program right now, there it is. It's moving along. I'm pressing lots of keys. I'm clicking on the mountains, the mouse buttons. I'm clicking everywhere on the keyboard. Nothing's happening because we haven't designed our code to handle any events yet. Okay? And the way that it's working is that we're going to be drawing over and over again. So what we're going to do is we're going to update. So we're going to change the x and y by dx and dy. That's a calculus way of saying the speed in the x direction and the speed in the y direction. So we're constantly updating that. And then we draw the ship. So the ship function just draws the ship. So it translates and rotates it. And we check to see if the laser is being fired. Right now, the laser is set to false. Nothing's happening. All right, so let's get it to actually change its direction. So what I'm going to be doing is I'm going to be using the key pressed. And you'll notice within processing that when you do that, it changes pink. That means that you're using a key variable that's sort of predefined within processing. Just like how the methods turn sort of a dark blue if you're using something that's predefined. This one's just regular blue, but we looked at another example over here where they turned a dark blue. So this is going to update, so it's going to change the position, x and y, applying the speed in the x and y direction, and then this is going to then redraw the ship. So we have our key pressed, and what we're going to do is if the key has been pressed, we're going to check the key code. We're using key code because we're using the up and down arrows, the left and right. So I'm going to first start off with the key code has been right. We're going to update the angle, and I'm going to do pi by 50. This is in radians. You could do the same thing by doing degree, calling the radians, and then do maybe like something like maybe 5 degrees or something like that. Otherwise, if the key code is left, we're going to move it in the other direction. So we're going to get the angle going to go minus pi by 50. Okay, so we're going to change the angle of what we're dealing with. Let's run that and see what happens. So now when I use my arrow keys, I can get it to change its direction in terms of what's happening. How am I getting that to happen? I'm just applying the transformations where I'm just using the rotation of the angle. Angle is a global variable. Update the angle in the draw, and then every time I tell it to draw the ship, it uses that angle in order for it to work. Okay? So that gets that to work. That's great. Now what happens if I don't have the key pressed? This is a common mistake. It starts to keep spinning. The reason why is because once I've pressed a key, the key code has been set, and it continues to be set over and over again. So every time we look and draw, we say, like, what's the key code? What's the key code? What's the key code? What's the key code? But because I've pressed something, it's going to be doing that. Now, if I just, let's restart that again. How could I get around that? Well, I could go in either direction. I'd have to press some key that I haven't programmed in order to get it to stop, which if you're doing that with an actual program, I think your users would get a little frustrated with you. So we have to check to see, has the key been pressed first in order for it to update? If you wanted to make it so that as soon as they change something, it gets it to work that way, you could do that. It would be a very hard game for sure. The next thing that we're going to do is we're going to apply this idea of thrust. The idea, what I'm doing here is some trigonometry. So I'm taking a speed, and then we're applying the angle. So we're going to figure, this is basically determining how much, given my current angle how much is it horizontal and how much is it how much of it is vertical. So I'm using some trigonometry here to help me with it. And then this is sort of how much of a change I want to make. So it's going to be very small increments because, again, if I change the speed a little bit, it's being applied over and over again. So it compounds pretty quickly. You can play with those values and you'll see that it causes some weird things to happen if it's too big or too small. So now what I want to do is I want to say, well, if they press the key code of up, so that's the up arrow, then what I'm going to do is I'm going to apply thrust. I'm going to call my thrust method, which again is going to take my current angle and adjust the X and Y speeds accordingly. So now that I've got that set up, I can angle myself and fire. And now I have sort of the basics of what I'm looking for. Okay, so that gives me the basics there. What if I wanted to get the spacebar to work? Well, the spacebar doesn't work under the key code. I have to use the key in order for that to work. So what I'm going to do for that is I'm going to check the key. I'm going to check to see if it's equal to the space character. Now, this is the space character. It's a single quote, not a double quote, which would be a string. We're using, the key is only a single character. It is not a string. So we use single quotes. And we can use double equals because characters are primitive. What I'm going to do is then, if the character has been hit, I'm going to turn the laser on. And I'm going to show you something. And then if it hasn't been hit, I'm going to make it false. Now this seems like it should work. I fire my laser, but I've let go of the space key. And the only time the laser disappears is if I change my direction. So if I release the space key, it doesn't make a difference, the space bar. So that's not really giving me what I want. I want to have it as soon as I let go of the space bar, it turns off the laser. So what I would do is then, if the key is not being pressed, I would set it to false. Okay, so if the key is being pressed, check to see what's going on, turn on the laser if you need to, change the orientation, speed up. If a key is not being pressed, turn the laser off. And now when I press the space bar, the laser is firing. I can change direction. Okay, but if I let go, it turns off. All right, so that's the key idea in terms of using the keyboard in order to get this to work. With a few modifications, we can get this to work with the mouse as well. So let's look at the same idea, same program, but using the mouse in order to get it to work. So this is the same program, but using the mouse. When we're using the mouse, in this case, I'm going to be using mouse pressed instead of key pressed. And I'm going to be checking to see the mouse has been pressed and what button. So if I've pressed the button and it's the left button, which is a regular click on a mouse pad, then it's going to thrust. If the mouse is being pressed and I'm pressing the right button, which is the two-finger press with a Mac, it's going to turn my laser on. If it's neither of these situations, it's going to turn the laser off. Okay, so slightly different in terms of what I'm doing there. Now, the other major change that I made in my code is I'm going to calculate the angle of the ship according to the mouse's position. So the effect of that is going to be that the ship is going to follow my mouse pointer now. Okay, so how is it getting it to do that? Well, I'm checking to see what's the y distance and the x distance. Okay, and then I use arctan2. If you use arctan, it will not work. You have to use arctan2. It's a special one for this kind of application. It will calculate the angle from the center, okay, from the origin, or from wherever you've calculated it. In this case, because I'm using transformations, the origin is right here. All right, so I'm using that to figure out the angle, and then I've applied that same idea when I'm doing the thrust. Instead of the angle being some variable that I'm keeping track of, I'm going to be calculating the angle on the fly every time. So now what can happen is if I press and hold, it starts thrusting, and if it passes the mouse, it flips around, and then I can get it to sort of float around, and it gives you a pretty cool effect. Looks almost like it's orbiting around the mouse. So it actually forms a bit of an orbit. And if I do a right click, I can get it to fire the laser while moving. Okay. And then if I just sort of pump the mouse as well, so click, 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 it gives me little bursts of speed. And I can get a pretty cool effect from that. Okay, so again, this is calculate. I'm using this angle effect to get it to follow, and then I'm using the mouse press to see if the mouse button is being pressed, and then using mouse button to determine which one is being pressed. And then you have different variables. You have left, right, and then there's also center. All right, so that's with the pulling idea, where we're using the variables to determine the events that are happening. What would happen if we did more